Hey guys, welcome back. So in this video, we'll be discussing on the third problem of beams. So this particular problem is based on uniformly distributed loads. So here we have two key points to be created with 2000 mm on the x-axis. So if we take the initial point as I and j, we'll have to be assigning these pressure loads over the beam of 4 Newton per meter, and the given cross section area is 60 by 90. Let's start the structural part in ANSYS Webbook. Okay guys, let's start with the structural part of problem 3 in the beams part. So going on with the preferences, structural and preprocessor, we'll select the beam 2D elastic 3 and clicking on OK, close it. So adding real constant. So clicking on OK. The area is 60 into 90 and the moment of inertia is 60 into 90 to the power of 3 by 12, and the height is 90. So I've entirely detailedly discussed on the real constant. So these three parameters have been discussed entirely in detail in the problem number 1 of beams. Please watch that video to get a clear information about it. And then going to clicking on OK, close it. So now we have added the real constant. We'll go to material properties, material models. Let's add the material model number 1. Going to structural, linear, elastic, and isotropic. The EX value is 2.1 e power 5, so which is 2.1 into 10 power 5. And the PRXY, that value, so this value is 3.1 e power 5. And the PRXY value is 0.3. Clicking on OK. Just close this window. And now we'll just move on to the modeling part by creating key points in active CS. So key point number 1 with initial coordinates as 0, 0, 0. Clicking on apply. The second key point as 2000 along x-axis and clicking on OK. So we'll just connect these key points with a line, straight line, and clicking on OK. We'll just move on with the meshing part. In meshing, we'll just directly go to size control, manual size, lines, all lines. Just enter the number of element division as 5, and now just clicking on OK, and then go to mesh. Finally, go to lines and pick all. So this completes the meshing part. Now we'll go to assign loads, define loads, apply structural. So we'll be assigning two kinds of loads, displacement load and pressure loads. So the displacement load would be on the first and third key point, first and second key point. So selecting the first key point, apply. So the first key point is constrained in all degrees of freedom. The displacement value would be 0. Apply. The second key point is constrained along ux and uy. So the displacement value should be 0 and clicking on OK. So we have added the displacement load. Now it's time to assign the pressure loads on the beam. Going to pressure on beams. So here we'll have to assign those loads on the mesh that we created by dividing 5 divisions on the line. Let's click on the line, we'll get the number of divisions over there. Just click on every division, 1, 2, 3, 4, 5 divisions. Clicking on OK, you'll be asked to enter the pressure value at node I and node J. So as discussed, we'll be entering the node I as 4 Newton. So on the given, we had a value of 4 kilonewton, which is converted to 4 Newton per meter as per the pressure units. So 4 and 4 will be added at node I and node J as it is a uniformly distributed loads problem. So 4 Newton per meter of pressure is uniformly distributed throughout the beam. So close the warning window. Now let's check the solution by going to solution, solve and current ls. So we'll get a note window as solution is done. Clicking on close and just close the window. So now once we are done with the pre-processing part, we'll go to the general post processor where we'll be defining a element table data. So here we'll be defining two important tables. So the shear force diagram and bending moment diagram will be those tables for defining. So just go to the element table in general post processor, going to define table, add. So I have completely discussed about this, adding the user label, adding the SFD and BMD values. So I'll just directly do it right now without wasting the time. SFDI by sequence now SMAC, 2, apply. SFDJ by sequence now SMAC, 8, apply. BMDI by sequence SMAC, 6, apply. BMDJ by sequence SMAC, 12, clicking on OK. So we have entered the labels for SFD and BMD. Close it. And now we'll be going to plot results. So in plot results, going to the counter plot in element result, line element result, we'll be getting the element table item at node I and node J. So make sure the node I is opted with SFDI and node J is opted with SFDJ. Make sure the selections are correct and click on OK. So here we have the shear force diagram displayed. Now let's switch to bending moment diagram by assigning node I with BMDI and node J with BMDJ. So clicking on OK, we'll get these exact bending moment diagram displayed. Some error would be because of the Poisson's ratio taken as 0.3 and 0.27. So note down those errors and you can proceed accordingly. Now we can go with the element list results. So in list results, going to the element table data, if we select SFDI, SFDJ, we'll get a list of results for minimum values and maximum values for SFDI and SFDJ. And similarly, we do it for BMDI and BMDJ. We'll get the same for them. And we can get the reaction solution as well. So note down these and we can even animate the current problem by going to plot controls, style, size and shape. Just click on the display of element as on. Okay. Again, going to plot controls, animate, and deform shape. Deform plus undeform should be selected. Clicking on OK, we'll get the animation for the current problem. So this completes the third problem of beams. And thank you for watching.